Okay, so when we're programming games, sometimes we like to have gravity involved. So we want to have falling objects that fall and behave like they would in a gravitational field. And we can use code to animate that motion if we understand the laws of physics. So I'm going to do a quick little introduction on how we can describe falling bodies with physics. In physics you'll get a lot more, but here's a quick little introduction. So first of all, there are mathematical equations that describe motion. So what we have are what we call kinematics equations. Now we have kinematics equations that describe position, that describe velocity, that describe acceleration, but all we really care about for coding is the position as a function of time. So we want to have an object and we want it to fall. We want to be able to do a set position in our code so we can trace and put where that little object where it should be. So we have two equations. One that describes the x position, and you treat the x position and the y position separately, so they each get their own equation. So what we say is x equals x sub 0, which means what is the position at time 0 before you ever start moving. So like if you're going to shoot something out of a cannon, where is that cannon, where is that little projectile right before you shoot it? So that's the initial position. V sub 0 x is going to be the initial velocity that it has when you first fire it. So that's going to be a constant. And then t is time, and that's going to be a variable. So what we're going to do is we're going to increment time, have time start at 0, and then go up a little bit, and then up a little bit more, and then up a little bit more, and increment time, and each time time increments, the position will change a little bit according to this equation. So v sub 0 x is the initial velocity. A represents the acceleration, that's a constant, and then we have t again. So what we see is that position x is a function of time based on these other little constants. Now we get almost an identical equation for y. The y position in kinematics depends on what its initial value of y is, what its initial y velocity is, and 1/2 at squared, just like we had for the other equation. All right, so these are general equations that describe motion for any scenario, okay, if something is moving as a function of, as long as the acceleration is constant, okay, so these are constant acceleration equations. Now, in a gravity field, objects are going to accelerate, but they're only going to accelerate in the y direction, in other words, vertically. So an object doesn't go accelerating, you don't go flying into the wall in front of you. There's no acceleration that's pulling you there, but gravity is pulling things down. So if you drop a ball, it's going to quickly fall at a faster rate until it hits the ground. So we only have to worry about gravity in the y direction, but we do have to worry about motion in the x direction as well. So these two equations will simplify, and they'll look something like this. We can get rid of the acceleration in the x position direction, and we change a to the value of g. So in our real world, we talk about Newtonian mechanics, we say the gravity has a value of 9.8 meters per second squared. So we're not going to use that value in our code. I mean, I guess you could, but we're just going to use a value that looks right to us. In other words, that has the game work in a way that it looks interesting and fun. So we'll play around with the value. But again, these values are all constants. That value, gravity, these are all constants. And our variables that are going to change are the t value and y and x. Okay, so we're going to have our code that will increment and change those values and then move the object around. Okay, so when you shoot a cannonball off of a cliff, what's important to realize is that the behavior in the x direction is slightly different than the y direction. Notice that in the x direction, going out here, it's nicely evenly spaced, right? Because there's no acceleration in the x direction. So with each little moment of time, this is like a little strobe light, the ball moves a little bit, a little bit, a little bit, a little bit, but that little bit is the same every single time. But the y direction is different because in the y direction you have some acceleration. So you have to account for the fact that you have this acceleration due to gravity. So in the y direction what you get is, I'm going to change color here, what in the y direction you get is it moves a little bit, and then it moves a little bit more, and then it moves a little bit more still, and even more still. And within each little snapshot of time, it moves further and further in the y direction. So you have to track each behavior separately, and we let the equations in the math do that. Now, when you combine those two behaviors, what you get is what you see here, which is the first position, and then the second position, and the third position. Because the y is moving down a lot, but the x is only moving over a fixed amount. So that's how you mathematically depict what we call projectile motion. Now, in this particular case, if you think about what's happening here, I've given it an initial position x and an initial position y. Okay, that's going to be defined right here, wherever that is in my coordinate plane. I'm giving it an initial velocity in the x direction, so it might have some positive value, like, oh, I don't know, 3. And then in the y direction, it does have a gravity value assigned, and I forget what I did in my code, I'll see it in a second, but there is no initial velocity in the y direction. In other words, I'm not throwing this thing down, I'm just shooting it off horizontally, so it starts off with 0 velocity in the y direction, and then it starts picking up speed as it falls down. Okay, let's look at some code. How do I code this? All right, we start by initializing our variables. So what you see is the first several values, x0, y0, g, velocity in the x direction 0, velocity in the y direction, those are all constant, so they're not going to change as we work through this little relationship. But these values down here, t, x, and y, we're going to start them off at a value of basically t is the initial value is 0, x is going to have x sub 0, and y is y sub 0, so I'm going to have x and y be set to their initial positions, and then I'm going to increment t as we go along. I've chosen an increment value that seems to work well for my particular code of 50. You can always change that, and you might want it to fall faster or fall slower, have time increment more quickly so it moves quicker on the page. You get to play with that. Okay, and then down here, this is a little function I wrote that just says resets the tomato. So every time I want to have it refire, I reset it, I put it back to its initial position. So here's the tomato right here, here's the tomato, it starts here, and then boom, I hit the button and it goes, and it comes down to the bottom. Okay, so let's look at more code. Right here, this is the function that determines what is going to happen. So let me erase it so you can see what's going on. This is the two equations. I'm calling this function proj-pos, in other words, projectile position. So this is a function. I'm going to call this function repeatedly inside a timed loop, and that's going to set the x and the y position as a function of time. So x is going to get set equal to x sub 0, whatever its initial position was, plus v sub 0 x times t, and that will set it. So t is going to start at 0, and then it's going to go up a little bit, and then up a little bit more, and up a little bit more. And every time it increments, every time this increments, then the x value is going to change. It's going to get bigger. And then the y value is going to do the same thing. Now the y function is slightly different because the y function has, it has the y sub 0, the v sub 0 times t, but it also has that 1/2 times gravity times t, or 1/2 gt squared. That's really important. That's what gets the object to fall. So I'm going to call this function, and it will assign values to x and y, given whatever the current value of t is. All right. So here is where I actually shoot the cannon. So I push the button, and whenever I click the button, it's going to fire the cannon. So it starts off with t equals 0. It sets the tomato in its original position, so x sub 0, y sub 0. I'm going to show the tomato. And then in here is my timed loop. Okay, so right here is my time loop, and I'm going to step time very carefully. And every time I increment time, then I'm going to go call that function projectile position. Right here, here's my projectile position. I'm going to call that, and with time changing, it's going to gradually, slowly update the position of my tomato. And so that's the part of the function that actually gets the tomato to move based on whatever the time t is. And then eventually I'm going to have a little check because my tomato is going to be falling, and when my tomato gets to a certain level, like a certain height, then I want it to disappear. You could have it crash and make an explosion and make a sound or whatever you want, but eventually I want it to stop so it doesn't go falling off the page. Okay, So that is all of the code that you need. I recommend that you play with it and get a sense of how it works. I will say that you can play around with these initial conditions. So these initial conditions right here, and so you could have your object wherever you want it, have your initial positions, x and y. If you want it to be going to the right, then your velocity in the x direction is going to be positive. If you want to go to the left, then you would make it negative. If you want to shoot it upwards, so let's say you're firing a cannon and your cannon's like this, and you're going to fire it upwards, then that velocity in the y direction, that's going to become negative, because remember, down is positive in JavaScript. So if you want to go upwards to start, then you're going to have your velocity in the y value be a negative value. And then the other ones are all the same. So just by playing around with your initial conditions, you can have your object fall or move to the right and fall. It could go straight down like this, or it could fall like this, depending on where your position is at any given moment of time. Okay? Good luck!